Hello and good morning. If you're watching this, Miss Klein is out because most of her family has the flu. I'll see you tomorrow, Thursday, and I'll remind you that homework 3 went out today, and homework 4 will go out tomorrow, and we'll have a quiz on Friday. Since I'm not here today, we will do the homework check tomorrow, Thursday. The homework check will refer to homeworks 1 and 2. All right, if you worked through these 4 solving problems, then you're ready to kind of hear what I have to say about things. So first of all, we're looking at the graph of f of x. Just make sure you can see why it's f of x. That plus 4 and that plus 2. Plus 4 moves it left 4, and then the plus 2 moves it up 2. That's why we have a starting point of negative 4, 2. We're being asked to do some solving things. Now, sometimes we can solve by looking at the graph, and sometimes that's a little more difficult. So I'll be curious to see what choices you made and how you solved by the graph or how you solved by undoing. So this first one, we want to know where the function equals 6. Well, 6 is up here. It's not quite visible on the graph, but I'll bet some of you solved it by graphing anyway. If you followed the pattern, we went up 1 over 1, up 1 over 3, up 1 over 5, and then it would be up 1 over 7. So 1, 3, 5, 7 would put us at, well, if this is 5 plus 7 would equal 12. So perhaps you found x equals 12 by graphing. If you didn't find x equals 12 by graphing, maybe you solved it. Maybe you said, well, I know that I can subtract 2, and that to undo a square root, I square. And so 16 would equal x plus 4, and by subtracting 4, you get 12. All right, so we saw a lot of that solving by undoing first semester, and we're seeing it here again with our square roots. Now, if we're looking at 10, where it equals 10, this next one here, 10 is kind of way up here. We could solve by using the graph, but it would take us quite a while. We'd have to extend this kind of forever. So if you solved by graphing, good for you. You are patient and persistent. I would suggest, though, that solving by undoing is our best option. Okay, so first is to subtract 2. Then we undo a square root with the inverse operation, which is to square it. So now we have 64 equals x plus 4. So if you got x equals 60, way to go. All right, this next one, this third equation, this now equals 3. 3 is nice and neatly located on our graph. So here is an output of 3. Look for where the input is 3. We can see that happens where x equals minus 3. You can test this to make sure. Right, minus 3 plus 4 plus 2. Negative 3 and positive 4 make 1. And since the square root of 1 is 1, 1 plus 2 is 3, so you can just check to make sure it works there. So that one's pretty easy to do by looking at the graph. Maybe you solved it by undoing. Maybe you were able to just sort of figure out by guess and check. How about this last one, though? Where does it equal minus 3? Well, I see minus 3 here on the graph. But I don't see that the graph crosses negative 3. So by looking at the graph, we see that there is no solution. But hold on a minute. Keep watching. If you concluded no solution and didn't think about it any further, I want you to consider this. If you hadn't had the graph to look at, if you only had the equation, you might think that your best option would be to solve by undoing. And so we've got minus 5 equals the square root of x plus 4. Now we can square both of those. It is possible. Minus 5 squared would be 25. And then we'd have x plus 4. Subtracting 4, we would get 21 equals x. So without looking at the graph, we actually might be tempted to say that the solution to this equation is 21, but we can see it has no solution. So what we're about to encounter with square roots is something we call extraneous solutions. All right, so you have to watch for those, especially on homeworks and upcoming quizzes. Watch for those extraneous solutions. Take a look at the equations on the next page. Give them a try. Watch out for those extraneous solutions. Maybe you won't be able to find them until you come back and watch the video. But give the next couple of problems a try, see what you come up with.